Okay, guys, good to see you. And hey, we're going to be talking more about proportional relationships, but now we're going to be talking about how do we see it on a table and a graph. All right. So we're going to be looking at the tables and trying to come up with how do we tell on a graph if a relationship is proportional. Then you're going to create the rules. Then we're going to look at some graphs and say, are they proportional from those rules? So this first problem says that a large museum, there are 150 people in each tour group. So let's think, if there's 150 in each tour group, and if you have two tour groups, you're going to have 300 people in that group, right? And if there's six groups, that's going to be 300 times 300, or plus 300 plus 300. There's going to be 900 people in that tour group. And then if there's 8 groups, well, that's going to be 1,200 people in that tour group. If you weren't quite sure how we did that, we multiplied each one of those times 150, right? Because there's 150 people in each tour group. Now what we want to do, if we look at this, we would say, the question would be, is this a proportional relationship? Well, if we understand, we just use that y equals k times x, because we just said the number of people, which would be our y, right? And x is our number of groups. We just said that y is going to equal k, which was 150, times how many groups we had. So that's our x, right? So k, the constant of proportionality, was 150. But now we're going to graph this, okay? Now notice that this graph is in even increments. In other words, it's 1, 2. It doesn't jump to 4 or 6. It doesn't jump by the table. So we have 2, 6, and 8. It doesn't go 2, 6, 2, 6, and 8. It doesn't do that, because that's not how you draw an accurate table, okay? Okay, so when we're graphing this now, remember this is our x and this is our y, right? So we're going to have 2 at 300. So that means we go 2 and 300, which would be right here. That's the point of 2 and 300. And then we have 6 and 900. So we come over to 6, and we go up to 900, which would be here. And then we have 8 and 1200. So we go on the 8, and we go up to 1200. There's that point. Now, what we're talking about is a relationship, right? There's a lot of points in between. We could have 7 groups. We have 9 groups. We could have 1 group. We could have no groups. And so what we want to do is draw a line that connects these points. But there's something we got to make sure you understand is that this point right here is called the origin. Okay? Okay, so we're going to draw a line connecting these points. Okay, notice what we get. 1, this is a straight line. Okay, 2, it passes through the origin. Now, we already know this is a proportional relationship because when we take 300 divided by 2 and 900 divided by 3 and 1200 divided by 8, we're going to get 150 people per tour group, right? So this is a proportional relationship. So this is proportional, okay? Okay, let's look at this one. Here's a relationship. Now let's graph it, see if what we see with the graph, and then let's see if it's proportional by doing our, we're going to say that we're going to have dollars per laptop. Okay, so graph this out. So again, we're going to have, this is our x, right? And this is our y. Okay, and so our first one is the ordered pair of 1403. Okay, so we're going to have 3 and 1400. And then we're going to have 4 and 1750. So there's 4 and 1750. And 6 and 2450. Okay, now draw a line connecting those dots does that give us what do we see with that? Okay, so we have a straight line, right? We can see that it's going to go in a straight line, but notice we have something here that it doesn't pass through the origin. This is the origin right here. For it to pass through the origin, this line would, and we can't just force it because this is the pattern, the relationship that we're seeing, right? Now, so this is a straight line, but it doesn't go through the origin. Now, we talked about the relationship up above, that when we looked at each one of these relationships, that when we wrote them as a ratio of number of people to number of tour groups, they came out, each one of these comes out to be 150 people per tour group, per one tour group. And so that is proportional because they all have the same unit rate, right? So let's look at this one. Is this proportional? So now right here, figure out your unit rates. What is it for dollars per laptop? Okay, so you calculate that and then fill it in and let's see what you get. So all I do is those first two, and I can see they're not the same. So for the first one, it comes out to $466.67 per laptop. And the second situation, where there's 4 laptops, comes out to $437.50 per laptop. They don't have the same unit rate. It's not proportional. So this one is not proportional. Now, notice the two graphs. They both make a straight line, but this one passes through the origin, this one does not. So if we look, we would say this one is proportional, this one is not proportional. So let's look at some other graphs. Okay, you have these three, right? Let's plot some points. First of all, let's notice this goes through the origin. This one does not. The origin's down here, right? It does not go through the origin. And this one does not go through the origin because the origin's right there. And this one does go through the origin, right? So this one, the origin checks. This one doesn't go through the origin. This one doesn't go through the origin. But this one does go through the origin. Now let's just pick some points. Let's see if they're proportional or not. Okay, I'm gonna make my life easy. I'm gonna pick the crosshairs, right? Where it goes through in the crosshairs. And I'm gonna look at those and say, are those consistent? So this is 15/1, right? Millimeters per second. This is 30/2 millimeters per second. And this one is 45 millimeters over 3 seconds. So if I look at each one of these, what's the unit rate? So this is already 15 millimeters per second, per 1 second. This would become 15 millimeters per second. 45 divided by 3 would be 15 millimeters per second, right? Look, they all have the same unit rate. So they have the same, it makes a straight line. It's going through the origin. I could say, yep, this one is proportional. Okay, let's look at this one. Okay, so let's see, we have 1200. Well, we're going to leave the 0 alone because we can't divide by 0, right? Okay, so we're going to pick another crosshair. Here we go, right here. This is 2,000 over 1 ton. $2,000 for 1 ton. And I'm going to pick this one here. That's $2,800 for 2 tons. Now, I'm going to just use the unit rate real quick because if this was proportional, this should probably, if I take this, I'm going to say this is $1,400 for 1 ton. That's how that would simplify. that automatically I can tell these two are not different, or not the same. These two are not the same. So if they have different unit rates, it's not proportional. This is not a proportional relationship. It is a relationship. There's a slope triangle to this, which we probably won't cover until the end of the year, but there's a slope triangle here because we go up 800 for every 1 ton we're increasing, right? And we can see that same thing here. We're going to go up 800 for every 1 that we increase, right? But that doesn't mean it's proportional, because we can see right here that 1,400 per ton is not the same thing as 2,000 per ton. So just to reiterate, it's a proportional relationship if it has the same unit rate, right? That's because then we can get a y equals kx, and we can't have that here. Here we can say y equals 15x, right? Because the 15 is the common ratio, right? The common unit rate. Let's look at this one then. Why don't you predict right now, do you think this is going to be proportional or not? I'd be asking thumbs up, thumbs down. Now check it. So we're going to grab a couple of these. So we're going to grab this point. We're going to grab this point. We're going to grab this point and ask ourselves, are these points, do they have the same unit rate? So again, I'm going to go y over x. So if I have y over x, that means I'm going to have $1,500 for 1 ton. And this next one's going to be $2,100 for 2 tons. So if I do my unit rates on this, this is going to be $1,050 per 1 ton. Well, so right away I can tell these two are not equivalent. So this is not a proportional relationship because their unit rates aren't equivalent. If the unit rates aren't equivalent, it's not proportional. So if you guessed this was not a proportional relationship, you should start asking yourself, well, I have these 3 examples right now. This one, the first one, example number 3, was proportional. Example number 4 was not proportional. The unit rates were not equivalent. This number 5 is not proportional. Okay, so it's not proportional. So what about this one? After using that observation, do you think that example number 6 is proportional? So just write down next to it, yes or no. Do you predict thumbs up, thumbs down? Now we're going to check, right? So we're going to look at this and we're going to say, let's look at these points, this point, and this point, okay? We're going to test them to see if they're proportional. So if I look, this is 40 miles in 1 hour. This is 80 miles in 2 hours. This third point is 120 miles in 3 hours. Now, do they have the same unit rate? Well, so this upper one that we have, that becomes 40 miles per 1 hour. The middle one, 80 divided by 2 is 40 miles per 1 hour. Are these the same unit rates? 40 miles per hour, 40 miles per hour. Yes, they are. So we can say y equals 40 times x. And so since it has a constant of proportionality, since each ratio represents a constant unit rate, then this is proportional. It's proportional. So now look at this, and do you see the pattern? Okay, just look at from a distance. This one was proportional. This one is not proportional. This one is not proportional. Example number 6 is proportional. even to look here at these two. Look at the graphs. This one is proportional. This one was not. Okay? We proved it by having the unit rates and seeing they didn't have the same unit rates. What would you say it has to be? What has to be true for these graphs to be proportional? So I hope you're seeing it has to be a straight line passing through the origin. So those are the two things. One, is it a straight line? And two, does it pass through the origin? Both of those things have to be true for it to be a proportional relationship. Okay, so let's look. Look at these four. Remembering those rules right there, right? Determine if these four are proportional or not. Put a check by the ones that are, put an X by the ones that aren't. Okay, so go ahead and do that quickly. Hit pause until you're done. Okay, so you should be looking at these four, and you should have seen that 7 is. Now you're going to have to defend it, right? On the quiz, you're going to have to tell me, yes, it is, no, it's not. And how do you know? Okay, this is proportional because it makes a straight line passing through the origin. That's what I would write. Straight line passing through the origin. Okay. The second one, example 8, is not, because even though it is a straight line, it does not pass through the origin. So this is not a proportional relationship. So this is how I would write my answers. So for example 7, I would say, yes, it's proportional because it's a straight line that passes through the origin. Both those things have to be true, right? That's all you have to say. Number 2, or example 8, we said, no, it's not. And you would say, no, it's not proportional. You could just say, because it doesn't pass through the origin. Okay, so then look at these two problems. What would you say? How would you write your answer for those two? If they are or are not proportional. Okay, go ahead and write that down and see if you write it correctly. Okay, so you would say this is not proportional because it doesn't make a straight line. That's it. You could say that it passes through the origin, but it doesn't make a straight line. You can add that to it, but the most important thing is you're saying why it is not proportional is because it does not pass through the straight line. Okay, so now defend your decision on example number 10. Okay, so you would say that it is proportional because 1, it makes a straight line, and 2, it passes through the origin. Those two things have to be true for it to be a proportional relationship. You can even double check by checking those points and see if they make the same unit rate. But what you'll see is it only works if it's a straight line passing through the origin. Okay, so now you take these two. Which one are they both proportional? Is only one of them proportional or none of them proportional? And then defend which one is proportional and why is it proportional, or which one is not proportional, why is it not proportional? Okay, finish this up. This is pretty much your quiz on this. So example 11 would be It is proportional because it makes a straight line that passes through the origin. How about example 12? So you should hit pause, determine if that's a proportional relationship or not, and then defend your answer. And you would say this is not a proportional relationship because even though it makes a straight line, it does not pass through the origin. That's it. So the gist of this is those two things, has to make a straight line and it has to pass through the origin, are the justifications on a graph to determine if a relationship is proportional. That's it. Okay, good luck. Come to class with questions. We got a quiz coming up on this. Just want you to be prepared. Have a good day.